All right, so there's this high school with 1,200 students, and someone started a rumor, and this is spreading logistically by this function. How many students have heard the rumor by the end of day 0? How do you solve this? Day 0 means what? Is 0 t or s? T. Yeah, s means student, so t is time. So s of 0 is equal to what? That's the question. So when t is 0, what is the answer? All right, we're going to have to solve the other one. Yeah, 30. Because this part is all 1. So just 1 plus 39, 40, so. All right, we're going to solve the other part tomorrow. So this is where we were last week. The question was, how long does it take for 1,000 students to hear the rumor? Okay, so kind of remind you of the equation. So you have this equation that's logistic equation. S means students, T means days. So if the question is, how long does it take for 1,000 students to hear this rumor? Where would 1,000 go? Does that go into T or S? S. So 1,000 equals to 1,200 over 1 plus 39 e to the negative 0.9 t. We gotta solve for t. This is very complicated. What do you guys want to do first? Please don't be scared. We're just trying to solve an equation just like before. You just need to take one step at a time. Yes, that's correct. So we're gonna just multiply everything by the denominator. That's usually a good start. Get rid of the fraction. Next. Yes, divide by 1,000. You really don't want to distribute 1,000 because now you're making it harder because you made the numbers bigger. Okay, 1 plus 39 e to the negative 0.9 t equals 1.2. What's next? Yes, subtract 1. 39 e to the negative 0.9 t equals 0.2. What's next? Yes, divide by 39. Let's not use our calculator at this time because the earlier we use our calculator, the more information we're going to lose because once you start rounding, the numbers get farther and farther from where they should be. Okay, we got to solve for t. That means we got to get rid of the e. Yes, we can do a log to bring that down. Now, what you want to do is you want to pick a log that is a base e, which is ln, natural log. So if you put natural log on both sides, according to our log rules, log of the same base with the same base, they cancel. So then that just totally cancels, and we just have a negative 0.9 t. Okay, the last thing is, divide by negative 0.9. So natural log 0.2 over 39 divided by negative 0.9. Okay, now use your calculator. Now remember, when you're using a calculator, please make sure you put closed parentheses. When you put natural log, your calculator is automatically going to open a parentheses. You need to close it before you start dividing. All right, so let me know when you have the answer. If you start getting negative answers, you know yours is incorrect because this is number of days. So we're not going backwards, we're going forward. So 5.859 around. All right, let's go to 3.3. All right, we're going to talk about logs today. So the first thing I want you to do is graph this on your graphing calculator. 10 to the x versus log x. So you're going to graph two graphs, one in y1, the other in y2. You're going to look at them and say, What is the relationship between 10 to the x and log x? Okay, so you should see two graphs. One looks like this. The other one, your calculator probably does this. This is not quite correct. You need to be smarter than your calculator. This is the log graph. The log graph actually goes down forever. But your calculator, for some reason, is not showing you everything. You need to mentally know this is going down. So I'm going to tell you now, this is one of the most missed things on the test. Every time I ask someone to analyze this graph, someone tells me the range starts there. The range does not start there. The range is all real numbers. If you just look at your graph on the calculator, you will not be able to tell. It does go down forever. Okay, so looking at this graph, these two graphs, what is the relationship between log x and 10 to the x? They're not odd functions. They're not odd functions, but they are inverse functions. So kind of think about it from a few chapters ago. If they can reflect over the line y equals x, they are inverse of each other. Okay, they are inverse of each other, but let's verify. So let's say that you have a graph that is, equation 10 to the x. How do I find the inverse function of 10 to the x? Switch to the x and y. Yes, very good. So we're going to find the inverse function. We're going to switch x and y. How do I solve that? I need to bring that x down, right? Yes. Now, which log would I need to use in order to get rid of that base 10? The common log, right? Common log has a base 10. So that cancels. So log x is equal to y. Therefore, proving that they are inverse of each other. In fact, you can do that with any log. So let's say the original function is b to the x. Then the inverse function will always be log base b of x, and whatever that base is. Okay, logs and exponential functions are inverse of each other. They're always inverse of each other. Okay, let's go ahead and have you try these now. Now that you know how to use your log rules, please try 1, 2, 3, 4, 5, 6. Okay, number 1 is 3, 2 is 1/2, number 3 is -2, 4 is 0, 5 is 1, and 6 is 11. All right, let's review 3 kinds of logs. Log base 10. Log base 10 is what log? Log, just log. And this is called a common log because we use it a lot. So we just don't write the base anymore. If you don't see a base, that is base 10. Log base E. Natural log, how do you write it? Ln. Ln, not I-N. I see this all the time, even in calculus. Please write Ln. It is not in or out. It's just Ln. If you write it I-N, I will make you write it over and over until you write Ln. It's embarrassing. Please write Ln. Logs with other base, then we just keep the base there. Okay, really quickly. 1, 2, 3. I just want you to write the base. I don't want you to simplify yet. Number 1, what is the base? 10. What is the base for number 2? Number 3? 4. All right, next. Don't use a calculator. 1, 2, 3, 4, 5, 6. Oh no. Okay. Amelia, number 1. Okay, so basically what you can do is you can do this loop thing. So log with no base is base 10, and you can loop around. So 10 to the what is 100 is the question. So x is, yes. Sally, number 2. Oh no. Oh. 5. Yes, they cancel. Natural log and e has the same base. Aaron, number 3. Yes, any log of 1 is 0. Number 4, Jennifer. Yes, 1 over 5. The Penny, number 5, sorry. Yes. And Iris, number 6. 1,000. Arnold, yes, question. Number 4? Okay, so you have to remember how to change your exponents. 5th root of 10 is 10 to the 1/5. So log base 10 and the 10 cancels, so just 1/5. Okay, the next thing is just make sure that you know where the buttons are on your calculator. So go ahead and just try them. Sherry, number 1. Okay, number 2, Blake.
I got negative.
That's right, that's right.
Negative 0.367.
Allison, number 3. 150. Sorry. Number 4, Eunice. 3, 4. All right, now we are going to analyze. Like I said, every single chapter. Okay, we're going to analyze this log graph. Now, before we do that, let's kind of look at the parent function. What's the parent function here? Log x. So, log x looks like this. Now, remember I said it goes all the way down, even though your graphing calculator is not going to show you that. What's the transformation on this log graph? 2 to the right. Okay. Now go ahead and graph and analyze. Okay, Alana, domain. Not all real numbers. We don't have any numbers on the left of something. Very close. Greater than 0 would be the original graph, but we moved 2 to the right. Yes, greater than 2. So 2 to infinity. Trey, range. Andy, continuity. Continuous. Josh, increasing. 2 to infinity? Yes. Evan, decreasing. Sorry, Ashley, boundedness. Unbounded. McKenna, extrema? No. Caleb, symmetry. No. Mark, asymptote. X equals 2, yes. And behavior, limit as x goes to infinity, f of x goes to infinity. Limit as x goes to not negative infinity, it never goes to negative infinity, it goes to 2. F of x goes to negative infinity. Let's analyze the inverse function. How do I find the inverse? First step, switch x and y. Next, how do I get rid of that log? Running out of time. Gotta raise by 10. That would cancel that log. So 10 to the x is equal to y minus 2. And then we add 2. All right, we're gonna finish this tomorrow.